Hello, Honors Algebra. Mr. Lawrence here with your flipped lesson for Wednesday, February 22nd. And we're going to be continuing to look at factoring special types of polynomials. Remember, we know three types of factoring, three types of the big F word right now. Three types of factoring. Remember, the first type is to factor by the GCF. And you always should try to do that first, always. The second type is called the difference of perfect squares. And remember, the difference of perfect squares will look something like this. You will have a perfect square minus a perfect square. It could also be a perfect square, a negative perfect square, plus a perfect square. Any one of those. And if you have those, they factor real simple. This one would factor as x plus 3 times quantity of x minus 3. This one could factor as negative 4 plus 5x and positive 4 plus 5x. If you wanted to, you could simply rewrite this with the x term first. Either way, it would factor the same. And then the third type of factoring is the perfect square trinomial. Okay? Now remember, I'm not here these couple of days. We're not meeting in class because of the field trips, but you should be able to stay up on the material. All right? There's really no excuse for not doing it. All right, I'm going to give you 3 sample problems, and then I'll do one from the homework. So, hold on one second. Okay, here are the 3 examples. See if you can factor them completely. All right, you can go ahead and pause the video, and then when you're ready to check all 3 answers, unpause. Of course, I'll do one at a time, so you can do one, unpause, stop, again, and go through and check. Okay, example 1, example 2, example 3. So go ahead and pause the video, work on at least one of the examples. If you're if you've unpaused at this point, I assume you're ready to see the red one. Example 1. Remember that the first type of factoring we should always try is GCF. I see a GCF here of 2. I'm going to pull out a 2, and I'll get x squared minus 25. The greatest common factor between 2x squared and 50 is 2. Now, I am not done factoring because inside, you see, I have the difference of perfect squares. I know that x is a perfect square. Its square root, x squared is a perfect square. Its square root is x. 25 is a perfect square. Its square root is 5. So this will factor completely as 2 times the quantity of x plus 5 times the quantity of x minus 5. And there you go. That is factored completely. All right, go ahead and pause if you haven't worked number 2 yet. If you're still watching the video, I'm assuming you're wanting to see me solve the second example now. First type of factoring I always try, GCF. I see a 5 is common. I'm going to pull out a 5. That'll leave me with an x squared minus 6x and plus 9. Remember, factoring out a GCF is like undistributing. Distributing is multiplying, so undistributing or factoring by a GCF is the same as dividing. So I divided out a 5. He goes out front because I can't just throw him away. Now I look at this trinomial inside the quantity, and I see I have a perfect square here. Its square root is x. I see I have a perfect square here. Its square root is 3. I multiply the 3 times the x and then double it. And sure enough, I get the 6x. So this one is going to factor as 5 times the quantity of x. What sign am I going to put for the 3? Well, I'm going to use the sign of the middle guy, minus 3. Now I have 2 choices. I could write it long ways like this, and that's a great answer, or I could write it like this. Either one will be acceptable. Okay, last example. I am going to factor out, we'll stop it if you haven't tried it yet. All right, I'm going to factor out a 7. It is common to both terms. And should I use the difference of perfect squares on the inside of the quantity? Well, Difference implies subtraction. Do you see a subtraction sign in here at all? No, I don't see one either. Okay, so this one is done. We wouldn't call it prime. This part of it is prime, but the whole thing isn't prime because I can pull out a GCF. All right, let me do 2 examples from your homework, and then this video for tonight will be over. So, let's see here. I am on 9.6b, and let me pick 2 good examples. Okay, the first example I want to look at is problem number 15 from 9.6b. All right, you have to fill in this question mark. I don't like a question mark there. I like a box or a blank. You have to fill that box in with the correct term that will make this a perfect square trinomial. Remember, for the perfect square trinomial, we need this term and this term to be perfect squares. When we take their square roots, we multiply them, double it, and we have to get this number here. All right, well, I'm going to work backwards. Normally, I would take square roots. I'm going to write the steps over here, but I'm going to do the backwards. So first I would take square roots of first and third terms. Okay. The second step would be to multiply the square roots. The third step would be to double the product from step 2. Okay, so I'm going to work backwards. I know that this number here is supposed to be double the product. So the first thing I'm going to do is divide it by 2. And I'm going to get 45xy. So when I multiply the square roots of this number and this number, the first and third terms, I have to get 45xy. Now I don't know what 2 things were multiplied by. Oh, wait a second here. Something is strange. I've written down this wrong thing here. This should be yz here in the middle, not xz. I better fix that, or Andrew's going to give me he double hockey sticks about it. All right, there we go. So, to figure out one of the factors, I'm going to take the square root of 25z squared. So I'll take the square root of this, and I believe the square root of that will be 15z. And of course, this here was going to have to be yz. All right, so now I know that this 15z was multiplied by something over here to turn into the 45yz, right? Well, I could, long ways, go 45yz and divide it by 15z. Of course, I know James is thinking, well, I would just know that it's 3 and I wouldn't have to do all that, or 3y, and he'd be right. But this is the way to do it. The z's will cancel. 15 will go to 45 3 times. I'll be left with 3y. Therefore, this must be 3y. But remember, that's the square root. So to go backwards, I'm not going to take the square root. I'm going to square it. So I'm going to square 3y, and it's going to turn into 9y squared. And there we go. The term that I have to fill in is 9y squared to make this a perfect square trinomial. All right, that should help you with a lot of your homework, especially if you were confused. Hold on one second. Okay, this is problem 20 on 9.6b. Pardon me, and it says the area of a rectangle is 16x squared minus 72x plus 81 units squared. Find the length and width of the rectangle in terms of x. Okay, well, the first thing I'm going to do is I'm going to draw my rectangle. Oh, wait a second. Where are my rectangles? There they are. Oh, what a perfect rectangle. All right, and I know the area is 16x squared minus 72x plus 81. And I know that to find the area of a rectangle, I have to multiply the base times the height. Now, I know the area, so I have to work backwards. Well, look at this. This polynomial, the area polynomial, kind of looks like a perfect square trinomial. Let's see. You know, I already checked GCF. I don't think there's a GCF in there. I know for a fact the factors of 16. 1 and 16, 2 and 8, and 4 and 4. 16 is not going to go into 81 evenly. 8's not going to go into 81 evenly because 81's not even. 4's not going to go in. 2's not going to go in. So the there is no GCF. But 16 is a perfect square. Its square root is 4x, 16x squared, that is. 81 is a perfect square. Its square root is 9. All right. If I multiply 4 times 9, I get 36x. If I double that, I get 72x. This is a perfect square trinomial. So I'm going to factor the red expression area, and it's going to come out to be 4x minus 9. Why minus? Because of this minus right here. And then times the quantity of 4x minus 9. And there it is. That's the base. And that's the height. Now some of you are thinking, well, Mr. Lawrence, isn't that a square? Yes, it would be a square, but remember, a square is a very special type of rectangle. Okay, a rectangle is a parallelogram with 4 90-degree angles. If the rectangle has 4 90-degree angles, which it has to, and all 4 sides are the same, then we call it a square. So a square is a type of rectangle. And there you go. There are the dimensions. It's 4x minus 9 by 4x minus 9 units. All right, Mr. Lawrence signing off. Have a good night, everybody.